Hi class, this is the section in using substitution method with exponential functions. We're just going to start with a couple of warm-up problems. So you see the problems here written, the integral from 0 to 1 at 2x plus 3 quantity squared dx, and the integral of e to the x plus 1 over x. So go ahead and write those problems down and work them. You can put me on pause, and we'll see if you're right. Okay, so you've had a few minutes to work the integrals. Let's see if you got them right. The first one, we can work a couple of different ways. We can use substitution method, which you're just learning how to do, or you can use your power rule. So let's work it using the power rule first. So the integral from 0 to 1, I'm going to FOIL this out to get 4x squared plus 12x plus 9. Then I'm going to use the power rule, so 4x cubed over 3 plus 6x plus 9x. I'm going to use my fundamental theorem now by plugging in 1 and subtracting what I get when I plug in 0, which is just going to be 0 in this case. So 4/3 plus 6 plus 9 is 15, changed into thirds will be 45/3, gives me an area of 49/3. Now, if I want to use the substitution method, we will see that we get the same answer using either method. So in this case, my u would be 2x plus 3. The derivative of that is 2 dx. So 1/2 du equals dx. So in for 2x plus 3, I'm going to replace that with a u. It is squared. In place of the dx, I'm going to put 1/2 du. So I use the power rule now that it's in u form. And I get u cubed, that will be over 6 from 0 to 1. I have to substitute my u back in. I'll plug in 1. 2 plus 3 is 5. 5 cubed, 125 over 6. Subtract what I get when I plug in 0. 27 over 6, 98 over 6, which simplifies to 49/3. So either way you work that problem, you're going to get 49/3. It does not matter to me which method you use, just as long as you're comfortable with either one. Okay, so let's look at the second warm-up problem. The integral of e to the x is just e to the x. But we're going to go ahead and rewrite it. We don't need to do that because the second one is just 1 over x, which is natural log. So the integral of e to the x is e to the x. The integral of 1 over x is natural log of the absolute value of x plus c. So that one was fairly easy. Okay, so let's talk about finding the integral. If it's not just e to the x, it is e to the u. So, finding the integral of an exponential function using substitution method. Okay, so there's going to be a couple different types of problems that you're going to run across using the integral of e to the u. The first type is going to be if there is just one e in the problem. So let's say it's x squared e raised to the x cubed. The first thing that you want to do is identify the fact that this is not just plain old e to the x. Because if it's just e to the x, the integral is e to the x. But this is e to the x cubed, meaning you're going to have to pick a u. The u will be the exponent when there is one e in the problem. Okay, so there's one e in this problem. Its exponent is x cubed, so my u is going to be x cubed. The derivative of that is 3x squared dx. I look at what's left over in the problem, x squared dx. So that means I want to solve this for x squared dx. So I'm going to divide both sides by 3. Now I'm going to substitute. So instead of writing x squared dx, I am going to write 1/3 du. And then I have the integral of e to the u. The integral of e to the u is e to the u. So once you get it in e to the u form, it doesn't matter if there's a constant in front or not, just pull the constant out, then we will get e to the u plus c. And then substitute in your u. So 1/3 x cubed plus c. If I want to check my answer by taking the derivative of this, so the derivative of 1/3 e to the x cubed is 3x squared times 1/3 e to the x cubed. So the 3's cancel out. I get x squared e to the x cubed, and that is what my problem was in the beginning, so I have integrated correctly. Okay, the second type of problem that you're going to have is if there are two e's in the problem. So what do I mean by that? Here's an example. E to the 2x plus 1 over e to the 2x minus 1. So there are two e's in the problem. So if this happens, it is usually going to be a rational expression. So in this case, you want the denominator, the whole denominator, to be your u. So in this case, u equals e to the 2x minus 1. So I am taking the derivative of e to the 2x, which is 2e to the 2x, and the derivative of -1 is 0. So then I just put dx. Now, I have to substitute in. This is not going to work. I need to erase this +1 to make this problem work. I'm sorry. Okay, so now it's just going to be e to the 2x over e to the 2x minus 1. So I have to substitute in for e to the 2x dx, which means I need to divide both sides by a 2. Now look what happens when I substitute in. My numerator is the same thing as 1/2 du. My denominator is my u. So I am going to integrate a 1 over u. So 1/2 natural log of the absolute value of u plus c, or 1/2 natural log of the absolute value of e to the 2x minus 1 plus c. Okay, I want you to try a couple for class tomorrow. So I would like for you to try the integral of e to the 3x plus 1 dx, the integral of 5x e to the negative x squared dx, and then one last one, the integral of e to the 1 over x over x squared dx. So do those three for class, and I'll see you then.